from the envelope follower.
This video is the third and final in the series on the 1630 Bode Frequency Shifter. Part 1, linked above, contains some background information and theory that is critical to understanding Parts 2 and 3. If you have not watched Part 1, it is recommended that you watch that video before watching this video. This video covers the last 3 of 7 applications of this unusual effects module. Application number 5, feedback suppression. Feedback in high-powered public address systems is a severe problem during live performances. A 1630 frequency shifter inserted in the line between the mixer and the power amplifier shifts the entire spectrum of the signal which drives the speakers. If the amount of shift is set at just a few cycles per second, then the sound appearing at the speakers will appear to be virtually unchanged to the listener's ears, but the regenerative effect which leads to feedback howl will be greatly reduced. This application enables microphone gains to be increased by as much as 5 to 20 dB. For the feedback suppression application, this is our setup. To our left, we have a microphone that's right in front of a powered speaker. The microphone is connected to the 2600 preamp input. The preamp output is going through an inline attenuator, and then it's going into the Bode Frequency Shifter. Out of the Bode Frequency Shifter is the line that goes back into the speaker. Also, this red connector connects to the mixer so that you can hear this. So you can hear now that there is no feedback. We're going to connect the speaker input to the preamp output, and immediately it feeds back. I want to point out a couple of things about the configuration. You'll notice that as I'm talking, this is the frequency of the shift, and it is in the LFO range, sub-audio. If I slow this down, the feedback will have an opportunity to build. The other thing I want to point out is that we're using the mix output, and we've got a balance between outputs A and B. So I'm going to change this frequency to a lower frequency, and you'll hear it feed back. Check, 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 check. And then we're going to take this output gate. Check, check. And we can tap on the mic. And when we speed it up, it's not going to feed back, even if we tap on the mic. Let me mention in closing that this technology is very interesting, but it's over 50 years old, and today we have different tools that are better at addressing this issue than the frequency shifter. Application number 6. The output of a tape recorder may be mixed with its input to produce well-known tape echo effects. The Bode Frequency Shifter inserted in the line from the recorder's output to input allows new tape echo effects. These effects are characterized by spiraling of the echoes either upward or downward in pitch. So we're going to implement this with a sequencer, a voice, and then the effects in this section. This oscillator is the clock. We have a single oscillator for the voice going through the filter, which is just doing static tone shaping. We've got an envelope and then a VCA. So in this section, we have the Bode Frequency Shifter. We have a digital delay, and this is going to replace our tape machine. We have a multiple and we have a mixer. So in order to insert this frequency shifter into the feedback loop of the digital delay, we've got to implement that feedback loop externally. So that's what we're using the mixer for. And we're taking the output of the voice, going into this multiple so that we can listen to it through the 2600 output mixer. And we're also taking that output, routing it into channel 2 of the mixer. We're taking the output of the mixer, going into the delay. We're taking the output of the delay, going up to the preamp in the 2600 to boost the level. Then we're coming back into the frequency shifter, and that's our input. We're taking the output of the frequency shifter and going up and out to the 2600's output mixer. Let's listen briefly to the voice so that we can hear what it sounds like unaffected. By the way, ignore the pitch. You'll see why we can ignore the pitch later. The only other thing I want to point out is that we're controlling the pitch of the oscillator and also the pitch of the frequency shifter from the sequencer from the same control voltage. And we have the scale set to exponential. We've got another control coming from the 2600 from the sample and hold, but we'll deal with that in a minute. Let's go ahead and listen to what this sounds like with the effect in. And you can hear the timbre change as the echo repeats. It's actually the pitch changing, but it's perceived more as timbre of a clangorous tone than it is a pitch change. Nevertheless, that's the effect, and it's a pretty interesting one. One thing I would like to note is that in getting this to work, I had to tweak a good deal with the levels going into this mixer. The output of this particular effects device was low, so I had to boost it. The levels were finicky, let me just put it that way. I had to devote a good deal of time to managing that. Also, rather than tuning these to specific pitches, I was really tuning them for how well they would resonate. And I will give you an example of how that can change dramatically. I'm going to shorten this to a 2-step sequence, and then I'm going to play with the first slider so you can hear the difference. The only other thing I wanted to demonstrate was the sample and hold. So we've got a very basic sample and hold setup here where the sample and hold is clocked from the sequencer clock, and the output is routed to the lag, which we're not going to use immediately, and then the output of the lag is routed to the control input of the frequency shifter. So we're using the sample and hold to send a signal to the frequency shifter to add some variation to this 8-step sequence. and we're going to control the amount of variation with the level on the sample and hold. And let's listen to that. We'll turn on the sequence. So that's application number 6.
In 3, 2,
1. Application number 7, speech processing. When the frequency spectrum of speech is shifted, its quality and apparent pitch are drastically altered without significantly affecting the intelligibility. So let's look at the setup. We had this microphone. It's going into the preamp on the 2600, coming out of the preamp, going through an inline attenuator, and from there it's going into the signal input of the frequency shifter. It's also going out to the 2600, and that's how we're hearing it. So that's our input, that's our output coming from the mix out, and we've got this set to output A only. We've got the scale set to exponential. We've zeroed out the frequency, the zero adjust, and we've got no gate on the output, no squelch. By the way, we're in exponential scale, and when you're in exponential scale, the zero is fully counterclockwise compared to the linear, where high noon is 0, and you've got plus and minus shift. So as I begin to talk, the first thing that we hit is some amplitude modulation, and you can hear this as a flutter. And as we continue,
it starts to get funky, and then it sounds like a helium balloon. And then it goes into very, very high pitch, and I don't know how I would describe it. So I don't know how I would describe that very high pitch. Somewhere in here, we've got an X-wing fighter. So that's the basic frequency shifting and the effects that you can achieve. Let's try one or two other variations on that.
first we'll try FM. So we're taking our triangle output from the external VCO, routing it through this attenuator, and as I speak, I will increase the FM going to the internal VCO in the frequency shifter. And now, as I'm speaking, I will raise the amount of shift exponentially. I'll continue to speak, and as we get into the audio range, it becomes very distorted, and I'll reduce the FM
Down, 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 down. And that's our normal shift. That's our normal shift. And I'll continue to raise the FM again. Check, 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 check. And now I'll shift the external VCO frequency
down to a lower frequency. Check, 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 check,
check, check, check, check. Testing 1, 2. Check, testing 1, 2, testing 1, 2, testing. Adding the FM from the external VCO. Check. Testing 1, 2, testing 1, 2.
In this test, we're going to take the output of the envelope follower and route that through an inline attenuator and put that into another input, control input on the frequency shifter. And then as I adjust this amount of attenuation, you'll hear the effect of this envelope follower affecting the amount of shift. So we're going to first raise the amount of shift to get some sort of effect going. And then we're going to increase the level going through the attenuator and get a frequency modulation from the envelope follower, which makes a pretty entertaining sound. And let's bring this down a little bit. This is a test. This is a test. This is a test. This is a test. And finally, take the envelope out, which is normaled here, and we're going to take the output of the lag and route that into our inline attenuator, and then take the output of the attenuator, route it into one of the control inputs, reduce the signal level. And as we're talking, we get this FM variation based on the envelope of the signal. That's pretty entertaining. And we can slow that down even more with the lag, which will make it have a slower attack. And this is a soft-spoken passage. The louder I go, the greater the amount of shift. Check, 1, 2, check, 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 check. There we go. Wow! Whoa! And there are 3 examples of the speech processing application of the Bode Frequency Shifter. Thanks for watching to this point. I hope you enjoyed it. This concludes part 3 of a 3-part series on the 1630 Bode Frequency Shifter. We demonstrated the last 3 of 7 applications of this unusual effects device.